Okay, I have started the recording. So let's get to the agenda. As I described, this is the agenda we have defined for the today presentation. And in best interest of the communication, I am switching off my video, right? At the end of the session, during the question hour, I will be again open or start the video. Thank you. So not wasting much time, let me get into the Statistica, right? Let me open the Statistica. You can view my screen, the Statistica interface.
No, sir.
Okay. Can you view now?
Yes, sir.
You can see the Statistica interface.
Yes, sir.
Wonderful, thank you. Yeah, so as you see the first interface of the Statistica, and today we have the defined objective like how we can perform the regression analysis using Statistica, right? So as we are aware, the Statistica offers you multiple resources for your self-paced learning or the self-paced evaluation, right? So we will be dealing with one of the example data set in order to perform the multiple regression. And suppose I wanted to get the help from the Statistica, the inbuilt resources what we have, I can go to the file, I can go to the help and support, I go to the help. Under the help, all the topics are listed under the contents window. If I go to index, because search or contents, today currently I have an interest in the multiple regression, right? I go to the Statistica example. Once I expand the Statistica examples, all the topics are listed under the Statistica examples. But currently I have an interest in multiple regression, right? If I expand the multiple regression, there are two example sets, or the two examples are described under the multiple regression heading. One is standard regression analysis. So once I expand the standard regression analysis, right, for multiple regression, another was the stepwise regression analysis, or that is all known as the rich regression, right? So two examples are given under the multiple regression. If I wanted to investigate before we get started with our analysis, multiple regression analysis, just we wanted to get an understanding about the description of the data, what currently we have in hand, right? So the data file has been described. The example is based on the data file poverty.star, right? What is the research problem we have in hand? This is more into a socioeconomic data, right? To analyze the correlates of poverty, that is the variable and the best predict the percent of families below the poverty line in a county, right? County means they have collected a different county in the United States of America, and they wanted to conduct a study for the poverty or which of the critical parameters or the input, right, which contributes to the poverty, and they will apply the adequate measures for this poverty elimination program under the poverty elimination program, right? So this is what we have, the problem statement or the research statement. I hope you have the understanding about the regression, right? Or if not, at least I can display few of the slides that will give you an introductory idea about the regression. So you can help me, need not to feel shy. If you know about the regression, straight away we can go and deal with the example data set. If not, I will run few of the slides in order to give you a little understanding about the multiple regression or the linear regression.
So we have a brief idea.
Okay. So what are the assumptions, like once we have a multiple regression, what are the assumptions we need to qualify to progress and perform a multiple regression? What are the characteristics of the data which qualify for a multiple regression?
The data should be linear.
How do you determine that the data is linear or non-linear? Linear?
So that we determine from the regression equation only.
No, regression equation is one of the output, right? But when we choose the algorithm, because the data qualifies for the multiple regression, because for all the algorithm, right, the data should qualify in order to perform that specific algorithm or the analysis. Same with the multiple regression or the regression also. Same with the classification also. Same with the cluster also, right? So there are certain basic characteristics the data should contain to qualify the data for a multiple regression or a regression analysis. Okay. The first and the one of the first and the foremost, right? The data, the input data, let me get the data set, because the example suggests we need to deal with a data set called poverty, and we are going to solve the research problem for which of the parameters contributes poverty. So this is the data set I retrieved from the example data set. What is the volume of the data? What is the volume of the data? Where we can see the volume of the data, or the data consists of how many rows, how many columns, where I can make it out?
So the number of columns is 7 here.
Yeah, fine. And what is the number of cases or the
number of rows.
suppose you open any of the Statistica file, you follow my pointer. On the top of that, it displays.
Yes, sorry.
Right. So you can see there 7V. The V denotes to your variable that has been structured in form of the column in the data set, right? And the C denotes to your rows or observation. So as I was talking, this data set from United States of America, this Benton, Cannon, Carroll, right? So these are the names of the county, as we have the different state here, like West Bengal, Odisha, Jharkhand, right? So they have collected the data from the various county or the states, and these are the input parameter. Right here I see the pop underscore chng. Right, suppose I wanted to see the whole description of this variable, where I can go and see the description of the variable. Because I cannot make it out anything, right? POP underscore chng, right? And many times what typically like if you decode your data in the short form, right? So where I can go and see the description of this data. If I go to the data for any kind of the data related or the data preparation activities, right? So there is a defined tab in Statistica, data. So under the data, suppose I go all specification, because I wanted to see the specification of this column or the description of this column, which is described POP underscore chng. So yeah, if I expand it, I see the pop underscore chng, right? The population change that describe as the population change, right? NEMPLD that describe to the number of persons employed in agriculture. PT underscore poor that has described as the percentage of family living below the poverty line, right? Poverty level. X underscore rate that the rate that is described as residential and farm property tax rate. PT underscore phone that describes. So this is the way I can describe. I can see the full description of this decoded or the short form of the variable, right? And many of the occasion also what happens, because let's say like I wanted to decode, and broadly you do in this design of experiment, you define these the various level in form of 0, 1 and all this, the level you define. So suppose you wanted to do something, the change, so you can do all this like the text levels, right? Okay, fine. So here for the multiple regression, right, we can perform using Statistica by the two way. I go to the statistics. Under the statistics, I get something called multiple regression, right? In addition to that, if I go under the statistics, if I go to the advanced models, I get, because since it's a general linear model, right? If I expand, I get this multiple regression. So there are two ways in Statistica we can perform simple or multiple regression. What is the key difference between the two approach? In this, under the general linear models, I get an equation also. And there I do not get an equation. That is the only difference, or some of the additional the output I get in your under the basic statistics. So since we will be dealing with this equation also, then I am getting into under this linear and nonlinear models. Okay, I wanted to perform multiple regression, right? As usual, I have to identify the variables of my interest, right? Here I see the two columns are here, and you observe, right? Most of the time, whenever you are performing or using Statistica, you checkbox things, so appropriate variables only. That will make your life much more simpler right? It will classify the variables by their characteristics. So here, okay, before getting into, can you observe something here, right? We had in the initially we had a question. What are the basic characteristics which qualify for a multiple regression? So do you observe something here from the data set? Do you observe something from the data set?
Sir, there's both dependent and independent variables to see.
Yeah, the dependents and the independents, fine, right? And see, all the variables are continuous in nature. Are you getting me?
Yes, sir.
All variables are continuous in nature, right? So this is one of the assumption for even like my target here. In this case, my target will be the percentage of poor living below the poverty line. This is also the continuous in nature. So whenever your input or your independent or your regressor will be in continuous in nature and your target also will be continuous in nature, then it will become a regression problem, right? Another assumption we need to, because there are certain assumptions for all the classical statistical analysis. Another assumption we need to qualify, the data should follow a normal distribution, but in most of the cases we do not get such ideal situation. The data will follow a normal distribution, right? Another assumption we have to qualify, there should be a correlation between, just underline this, there should be a correlation between your target and your input variable, or your dependent and the independent variable, right? What we say, the linear relation, right? So there should be a correlation between your dependent and the independent variable. But mind it, another assumption, there should not be a high correlation among your independent variable. Are you getting me? The assumption is that
Yes,
there should be correlation and a linear relation between a dependent and independent, right? But there should not be high correlation among your independent variables, else it will become a problem of collinearity, right? So what typically, depending on your judgment or depending on your data set, like you can define some threshold for the collinearity. Suppose the correlation is among my independent variable is above 80%, right? I should drop the variable, right? So that is
so
the
what does continuous mean here?
hello.
So what does continuous variable mean here?
The continuous variables means, you see the numbers, right? The age basically we record the age in terms of let's say 1 to 100, right? Or maybe 1 to, right? So this is in numbers, right? We record the marks in numbers, right? 20, 30, 50. So these will become the continuous variable. This is the characteristics of the continuous variable. Wherever I get numbers, right, that it becomes the continuous variable, right?
Okay, sir.
And the characteristics, like suppose we have something like your pass, fail, right? Or the height is low, medium, heavy, or right? So these are recorded in terms of the category or the various different labels, that become your categorical variable. Fine.
Okay, sir.
So here in this case, in regression, your target as well as your input has to be, the variable has to be continuous in nature. Fine. And the collinearity. And suppose you wanted to identify the correlation between the variables in a click of a button, which of the typical graph we use for the correlation analysis? Which of the popular graph you? Hello?
The scatter plot.
Yeah, wonderful. So let's do a scatter plot just to get a sense of our data set, right? So all the graphs you get, under the graphs, you get a variety of the graphs using Statistica. So I went to the scatter plot. Again, the rules will remain same. I just pretty poor because I wanted to guess a correlation between my dependent and independent variable. Let's see. Okay, it gave me one by one, but I wanted to get everything in under one. So I choose the multiple. I go to the advanced and I go how you measure your correlation? Because it is very difficult, right? From this graph to make it out what is the correlation between your pretty poor and age, right? It's very difficult. So how do we measure the correlation?
Capital R.
Yeah, capital R. So I select, I went to the advanced. I select this R, right? I can get all these things, but you can give a try whenever you are doing your practice session. So let's see. Okay. So I got this, right? So can you do some interpretation out here? Which variable is the best linear fit between your dependent and the independent variable? Or which variable has a good correlation or a good variable to consider for this regression analysis?
So poor and phone.
Yeah, PT poor and PT phone, the R square suggests it is the 0.53, right? Among all these 6 variables, right? The phone is a good variable to consider for your, that we will see during the course of this prediction. So this is the way, like suppose you wanted to get, and in Statistica also you have full control over these graphs. Suppose you wanted to change anything in the graph, right? Let's assume I wanted to change my marker to this thing. Let's fine. So you have the whole control over the properties of this graph. If any kind of the changes you wanted to make for a beautiful visualization, so you can go click there, get into the property of the graphs, and you have the full control over this graph for any kind of the beautification or any kind of the specification you wanted to embed in this graph, right? You wanted to change the name or something, anything you can do, because you have you are the owner of this property of this graph, which has been generated as an output, and you can do any of the beautification or any of the changes you wish to make it with the graph. And that is one of the strongest area of the Statistica. Statistica typically known as the king of visualization, right? So you can interact with the graph for any kind of the changes in this graph. Fine. So let's get started with our analysis. I go to the statistics, I go to the multiple regression, I go to the start new variables. Now we are aware that we are dealing with pretty poor as our dependent or the target variable, rest of my independent variable. I can go to the advanced. Suppose I wanted to do, because there are few options are there, as we saw, right? Advanced option like the stepwise or the rich regression, right? Suppose I wanted to perform a stepwise or the rich regression. Stepwise means one by one I wanted to deal with the input variable, right? So let's go with the default specification. I can define my alpha, but currently we can go with the same. We can go with default specification, summary of the regression result, regression summary for dependent variable, right? As we know, we have defined our dependent PT underscore poor poverty. R is equal to 8821. What does it mean? R symbolize for what? R symbolize for what? That is nothing
Coefficient
that
for multiple determinations.
no. The R is basically for the correlation, right? So since we are getting the 88, right? So these what the variables we have considered, what the variable we have considered to build our this model. These are the good variables, right? Because what was one of our assumption for the multiple regression? There should be a good correlation between my dependent and the independent variable. So that assumption we qualify out of getting this number. R is equal to 0.88, right? So what we have considered that the input data to build a predictive model for the poverty elevation, this data are good. Then we have got the R square. R square is 0.77. What does it mean?
Coefficient of multiple determination between the dependent and independent variable.
Yeah, so suppose because this range of the R square varies from the -1 to 1, right? So what I get here, because the variability or the power of prediction of the variable, the input variables I have considered, right? Then again, it getting more evidence, right? The variability are explained by the input variables is the 77. So the predictive power of the input variables is, so the more I get this R square, I can think I am getting a good model, right? My prediction. So whenever someone asks me, once I do the prediction, what is the accuracy you can claim from your this regression model, you can say I can claim around 77% of the accuracy the model will give me, my prediction will give me. What do you mean by the adjusted R square? The typical, like in the layman explanation of this adjusted R square, always the adjusted R square has to be less than your R square, right? And typically, like suppose I include another, because now we are considering 6 variables to build the model. Suppose I include another one variable, right? 7 number variable, my R square will automatically increase. Suppose I include any of the extra input variable, my R square will increase, but that will not be necessary with the adjusted R square. And another assumptions are there. right? Suppose I'm getting this R square and the R adjusted R square very close, right? The more closer, more better. Then I can claim that if, because I have built this equation on the basis of the 30 data points, right? 30 data, this observation I have. But once I would like to deploy the model, deploy means once I receive the data set, let's say from another different 10 county, or maybe let's assume different 100 county, right? So if my adjusted R square and the R square are closer, I can claim I can deploy 100 data set and the result will maintain a consistency. Fine. What do you mean by this F? F is, this is basically the degree of freedom. So we had the 7 overall variable, 7 minus 1 and minus 1, 6, right? We had 30 number of observation, 30 minus 7 is 23, right? So, and the error of estimate, because the error of estimate is like the error, right? So the less number of error I get, basically that is the corresponding to all this number, R square adjusted R square, right? So this is the corresponding to all this. Then I get something in this output spreadsheet, I get something in the red. What does it mean? What we had observed, what we had observed from our scatter plot. Okay. Okay. Yeah, these this PT rural, right? Whatsoever has been coded, you observe the p-value, right? You observe the p-value, right? These the p-values as the less than 0.5, right? So we can claim this population change and the PT rural, it has got a significant impact on the people living below the poverty line, right? On the basis of the p-value. Fine. Another things you can see the B. You can make a note if you are in a position. You can take the note of this numbers, what like the 31.26604, then population change. The B denotes to your beta coefficient. And this is also is very one important component of your regression analysis, not regression in any of the analysis, the predictive analysis you carry out, right? So what is the interpretation of this? I get the under this p, small p, right? Or what you say the beta coefficients, I get 31.26604. As intercept, right? What does it mean? Okay, you take this this thing. I get the minus 0.39234 in the row of the population change. The interpretation of this beta coefficient is, suppose I increase, mind it, I increase 1 unit in my population change, right? If I increase 1 unit, my population change, right? If I will increase, then my poverty, right? The percentage of people living below the poverty will decrease to minus 39. So there is a negative. There is a decrease in this, your poverty. The similarly, suppose I increase 1 unit in my not employed, right? So there will be an impact of 0 in my PT poor or percentage of people living below the poverty line. So this is one of the important components, coefficient, right? I can determine the impact of this input to my overall dependent this thing. Even there are multiple studies around, you'll find the various interesting output. Once I was going through one of the article, I saw there was a heavy impact of the categorization of the criminals who are living in the Tihar jail out of the having the brinjal, right? So there are so this is the one way like you can figure it out, the impact. If you increase one unit in your independent, what will be the impact, right? The individual impact on your dependent variable. Then I get a ANOVA, right? The same ANOVA tables we are aware of. We can make the interpretation. Perform the residual analysis. Have you heard about this residual analysis? What do you mean by the residual? What do you mean by the residual analysis? You concentrate on this number.
R square minus adjusted R square.
No, this is basically the observed minus predicted, or what we say the error terms, right? You just concentrate on this number. Observed is my 19 and my predicted value is 1904. So observed minus predicted, I get the residual. So there is an error of minus 0.04. So the residual is like wherever we calculate the residual means observed minus predicted. And here also, in addition to our R square, we can also calculate the goodness of fit, where typically we say the model evaluation. I build a model, I wanted to evaluate in terms of the accuracy of the model. So you just mind it, the Statistica offers you any of this output, I can take as an input. So this is one of my output, predicted versus residual. Under the residual analysis, I go there and I select use as active input. Fine, use as active input. So once I click that button, I saw there is a square has formed around this data set. Fine. What is my purpose here? Again, I wanted to evaluate my model accuracy, right? Any of the term you have heard before, like mean square error, root mean square error, absolute mean square error. Have you heard of something like this before in any of your research paper or in context to this thing?
Yes, sir.
Predictive analytics, right? So for the regression analysis, right, these are the technique we apply for evaluation of our regression model, right? Or the regression model, right? So here I choose this. I went to the data mining. Under the data mining, we have a feature called goodness of fit, right? I went to the goodness of fit. I have an objective in hand. I wanted to evaluate my model. I go to the variables. Here, I'll put the observed value and the predicted value. Okay, right? And I go with this selection. Summary of goodness of fit, right? Mean square error is 8 point. You take a note of this. we will make a comparison where we will be using the neural network, right? We'll using the same data set, we'll build a model and we'll see the accuracy of the model, whether my multiple regression is working better or my neural network is working better, right? You can take a note of this 8.85 and 2.46. Fine. So the next question comes is, again, you get multiple output here in Statistica. So during your learning phase, you can explore each and every features you see in Statistica under the multiple regression. There are many things, many output will be there, right? But just in best interest of time, I applied few of them. Fine. Okay. Why I have been doing all these exercises? What is my larger objective? What is my larger objective here? I am building an equation.
Sir, here we are dealing with 30 data, but in future we can deal with the same equation. We can deal with 3,000 data for a larger data set.
But what is the purpose? What is my objective? My broader objective? Why I have been doing all this? 30 data, 100 data, 1,000 data.
But what is regression equation?
What is the purpose of that regression equation?
Sir, so that we can omit the experiment part.
No, all evolves around the prediction. Right? Suppose I take a situation.
Predictive equation.
Yeah, it's all evolves around the prediction. Even suppose you have the data set under the various parameters, right? And you build a regression equation, you can predict how would be the weather tomorrow in Kolkata if the data set qualifies like this, right? Even you can predict, right, how the weather would be for the 7 more days, the future day in Kolkata. Fine. All evolves around, it is a part of the predictive analytics, prediction, forecasting. Why all we have been doing? So the next time, once we receive, you mind it, once I get this, I get something called in these features called report, right? If I go to the report, I get something called prediction equation, right? If I click the prediction equation, I get the equation for the models, right? What is the equation for a linear regression? Y is equal to
MX plus C.
Yeah, or you can like Y is equal to A plus BX, right? So I had asked you to take note of something, right? Some of the beta coefficients we had got as an output. Where there were somewhere like 31.266. Suppose I break this equation to Y my target, PT poor, A denotes to my beta coefficient. Sorry, A denotes to my intercept, right? And we had seen somewhere minus 0.39 something. One sec. Can you view my screen?
Yes, sir.
Right. So take this note of this number and you fit the number in this equation. So what you can make it out? PT poor is my target. Y is equal to A plus BX. A is intercept. What we got this number 31, right? B described as the beta coefficient, what we saw just below in the rows, minus 0.39. POP change, that is by the name of the variables, right? Or I can say X, right? X1, X2, we have the 6 variables, so we can put it X1, X2, X3, X4, X5, X6, depending on, because this population changes denotes to my X in the equation. So now I wanted to deploy this equation. Fine. There are multiple ways we can deploy this equation for the purpose of prediction. I made a copy of this equation. I go to the data. This is one of the simplest way to deploy the equation in Statistica. I go to the data. I go to transform. I just paste my equation here. Fine. And I apply this expression. Okay. Since my mathematical syntax is fine. Yes. One second. Fine. So I got this prediction. Fine. I got this prediction. Fine. But let's assume, as we have been talking about the more, suppose I wanted to deploy this equation. Fine. So I have a assume, go to open file, go to the open. Right. I have a data set I have prepared for you under the GU property example. The data set are there in X as an example file, property example. I wanted to bring into Statistica. Okay, I got this. Just make an observation from this data set, right? So here what I have done purposefully, I have added 2 new county in form of the 31 and 32. Are you getting me? Right? I received the data after I built the model. I received the data of West Bengal and Odisha. So just I wanted to get a sense what would be the percentage of poor living below the poverty line. Now I have an equation. So again, I go to the transform, apply my formula here. Okay. Did you observe something here? Did you observe something here? You see the row number 31 and 32. What was
Yes.
missing in, right? In
Predicted
the row.
poor is blank.
Yeah, so the prediction has given, right? The prediction has given for the rows number 31 and 32, right? So that is the prediction. Suppose I would have added more 20 rows or more 10 rows, that does not make any difference, right? As long as, because we have evaluated the model, my R square and the adjusted square were closer. So we can assume the model will be a good fit, right? Another way also you can do this. I got the equation, right? I got the equation. Let me open the data set in Excel.
Yes, sir.
So this is there are multiple ways you can deploy your equation. Even suppose in absence of a Statistica also, if you wanted to do the prediction using Excel also, if the equation is in your hand, you can accomplish the task of prediction. And this is the way you can deploy. And in present of Statistica, you can go to the data transform and you can deploy the equation. Fine. So let's get started with our design of experiment.
So you said that the example you have given for this mean square error and mean square absolute error, you'll be explaining this part with the ANN model. So can we do that first and then come to design of experiments?
Not see the ANN model, right? Okay, fine. Let's get into the neural network since this is right. I go to just open it. Data mining. Under the data mining tab, I get the neural network, right? The AI or the neural network. In addition to that, suppose you wanted to explore something very advanced algorithm for the same data set, because it is not necessary every time the neural network or the AI will work. As a researcher, you can experiment. We have the algorithm from the machine learning also. And under the machine learning also, okay, on the data set, I go to property. I go to data mining, neural network. Under the neural network, I can solve 5 types of problem using Statistica: a regression problem, classification problem, time series regression problem, time series classification problem, and cluster analysis. So out of these 5, hopefully, like depending on the time permits, we'll be dealing with the 3 examples: regression, classification, and time series regression, right? As I said, because the data qualifies for the regression, right? So let's perform the regression analysis using your Statistica automated neural network. Fine. The rules, the approach remains same. I wanted to identify the variable of my interest. PT poor is my dependent, and is my independent. Okay. You observe this neural network interactive dialog, right? Once you expand the neural network, you get 3 options: automated neural network, automated network search, ANS, custom neural network, CNN, some sampling, random sampling, right? I hope you understand the neural network, right? A little understanding of the neural network is there, right? The custom neural network, because neural network, the most critical component to build a neural network, to define your hidden layer, right? So suppose you are accustomed with the neural network practices, you can choose for the neural network where you can define your own specification. If you are new to the neural network, you can go with this automated network search that will guide you the step by step how to build a neural network, right? Sampling. So here all the data set is very less, but anyway, right, I have an option. I can split the data set, training, testing, and the validation, right? broadly, whenever we talk about machine learning, artificial intelligence, deep learning, broadly, we split the data set for academics like the training and testing, but in the industry environment, we split for the validation also, because the validation data, we apply the validation data for the purpose of the production, real-time production. But here, since the data set is very less, we'll be splitting the data set into training and the testing. 0, right? Let's go with this selection.
Sir, can you please show for the validation also, as this is only for learning purpose, then we can see for all the parts.
Yeah, you can split the 15, 15, right? 15, 15. That was by default the specification, right? So we can split the data. 70% we have kept data. We have holding the data for training. 15% we have holding the data for testing, and 15% data we have hold for validation. All right. Let's go ahead with this specification.
So what is this seed for?
Yeah, seed basically what typically whenever you split the data, training, testing, validation, right? So it picks up randomly, right? So suppose you define a seed, right? It will begin from there. Right. So here you see this is
Sir, could you repeat once more?
Which
there
one?
was some network issues.
Okay.
Sir,
Okay.
When do we? Yeah, about the seed thing.
Yeah, the seed value basically whenever we have defined the specification for the training, testing, and the validation, the split happens randomly, right? It will pick up randomly. Suppose you define some kind of the seed because that is the starting point of splitting the data. Right? So you can view my screen now.
Yes.
Hello. You can view my screen that describe one of the window that describe network types MLP and RBF. Hello.
Yes, sir.
Okay. So since I'm a beginner, I do not know much about the neural network. I choose both this MLP. Have you heard of this MLP? Have you heard this MLP before in any of your research paper? Because this is one of the very, very popular network. Stands
the
for
multi-layer perception.
Yeah, multi-layer perceptron. Yeah, that's a very popular neural network model, MLP, right? Multi-layer perceptron. And since we are the new, we do not know which of these, but RBF broadly applied to solve a classification problem, right? We also choose that RBF also we have chosen. What does it the RBF define to?
Sir, I don't know RBA.
Yeah, you can have, that's a radial bias function. And what you have been talking about the back propagation, this is where this back propagation works, right? And in the right hand side, we see network to train, that is the by default has come network to train 20, means I will be training 20 networks, neural networks, 20 neural networks I will be training, network to retain 5. Out of the 20, I will be holding the 5 best out of this 20 network I built, right? Then I go to the MLP activation function. Under the MLP activation functions, all this neural network built by using these mathematical functions, right? Since I do not know which of the mathematical functions it will work, suppose you use any of these the software, what typically you do, you write the syntax and you define all these activation functions, right? right? Suppose for you wanted to apply sine, right? Then you need to write sine, then some of the syntax, then, but all these mathematical activation function is very popular, right? And another new which Statistica is not support, or Statistica does not support, called ReLU activation function, right? This ReLU stands for rectified ReLU function. That is one of the popular activation which has come very recently, the ReLU activation functions. Then we have the weight decay. Weight decay is basically, if you see the structure of the neural network, your input layer, then hidden layer, then your output layer, right? So the error you permit to build your network, or the scope of the error. So suppose I click here, this is the minimum error we allow for to build the network, or to release from input crossing over the hidden layer, right? So this is the error we permit to predict the output, hidden layer. Initialization, let's fix it. Okay, again, this is the same seed value because I am defining some, so this will begin. Now I go to the train. Can you view my screen?
Yes, sir.
Okay, so let's investigate n. Basically, that is the number of network we have hold, because we had chosen, we wanted to hold back 5 best network out of the 20. So the five best networks have been ordered in terms of their accuracy. Here, the first I am getting the training error is 67, right? My testing error is 0.9, and my validation error is 87, right? So I choose this, select, I choose this, I see this, right? And right. So here I have also the 3 predictions are there. Standalone, ensemble. You must have heard somewhere the assemble model means. I would have taken all the 5 best network and I would have calculated an average from the 5, right? Let's go with this prediction. Fine. I got the prediction, right? So can you let me know, like, what is the percentage of the prediction, or what is the accuracy? How do we evaluate the accuracy? What we did in the last time? What was the MSC mean square error in multiple regression? I asked you to take a note of that. What was the mean square error of the last model we have built?
Sir, it was 8.855.
Wonderful, 8.85. So now this, with the same data set, we have applied an AI, or the neural network, right? So how can we claim out of this classical statistical algorithm, multiple regression is good or neural network is good? So the same process I will follow. I will take this as an input, use as active input, right? I want to the goodness of fit, right? I go to variables, pretty poor output. Okay. What does it mean? You can view my screen now.
Sir, here the mean square error is much mean square error is much more than the previous one. Even the mean absolute error is higher.
What is the conclusion? What is the interpretation?
Sir, in this data, NLP doesn't work by RDF.
In these particular, in these
Or
data, in the
ANS
data,
cannot be used.
yeah, because no, ANN can be used, but always I have gathered enough evidence. Suppose someone asks me why you have built a multiple regression model, right? I do have enough evidence I have gathered to suggest that yes, I also use the advanced algorithm of ANN or the AI, right? And the similarly, like you can use the algorithm like machine learning, like support vector machine, and you can make a comparison. And once you publish your paper, you have gathered enough evidence, the algorithm you have used the best algorithm in best interest of your accuracy of the prediction, as well as in best interest of your data. So this is the way like you can evaluate your model, right? So let's go into this. What else output I generate here? Prediction, graphs. I get a variety of the graphs here. Right, even the scatter plus suggests me that it is not. What typically I will ask you, right, when you go this thing, you follow the same process in best interest of the time. At least we can touch upon the other two what we discussed. You go to the file, right? I wanted to get started with the neural network. I go to the help and support. I go with the help. Under the help, I go data mining. You follow my pointer. I want to data mining. Under the data mining, if I expand, I have Statistica automated neural network, right? If I expand the Statistica automated neural network, right? There are 6 examples has been listed here. Performing regression with 4-bar linkage, iris classification, we are going to deal it now. The growth in number airline passengers over time. If the time permits, we will be dealing with this growth in number of airlines also. Then time series classification, cluster analysis, deploying the bar linkage, right? But in a quick, like how this we can deploy this model. Another tricks of deploying this model in Statistica also. Just mark it. We have this safe network, right? If I expand the safe network, I have something called PMML. The PMML stands for predictive model markup language, right? If I click the predictive model markup language, right? And I save this model in desktop, send PMML code property. I close everything. Now I bring the same poverty example. I have the new 2 cases here. I wanted to deploy this PMML. Just above the goodness of it, I have got something called rapid deployment. I went to the rapid deployment. Load models. You just check this variable selection by PMML, right? I build a model. I have saved the model in PMML, which stands for predictive model markup language.
Sir,
Yeah, please.
two sets of essays in model.
Yeah, because the
predictive
two of the new data set we had inputted, but we did not have our target there. So the two new cases we have predicted out from our deployment, right?
okay, sir.
So this two is a new cases we have predicted. Now we have
Okay.
the three approaches for the model deployment for the purpose of prediction. What are those? One, the most simple way of deploying a model or deploying an equation through using Statistica transform, which I get under data. Another way I can get that equation, I get this the PMML. PMML stands for the predictive model markup language. Through the PMML and through the deployment, I can deploy this model for the purpose of the prediction. Another, in absence of the Statistica also, I can deploy the model in the equation in Microsoft Excel also. Fine. So now we have the three ways. Yeah, you are correct. In addition to this PMML, but all these languages we do not sell to the academics. We have, once I explain, you get PMML, PMML4, you have the C, C++, C#, Java, SAS, SQL Store, right? So for academics only, we sell the PMML, that is bundle in this package, right? But suppose you wanted to like the other languages, right? I can give an example what typically the industry they do, right? We have made a model, right? We have made a model and this code has been saved in the C#. So now I can run this API, right? I can run this interface in absence of a Statistica also any of the machine, right? And I receive a new data set of West Bengal and I wanted to predict the percentage of people living below the poverty line. So we have some data, example data set like population change 13.7, or I can input also in best interest of the time I have streamed the data. Alternatively, I can input also, right? The new data I will receive. And if I will do the prediction, it will give me the prediction 19.0428, right? I get the prediction equation, right? And suppose you have some kind of the mechanism like in West Bengal government, like suppose they can stream the data, the real-time data from the various field, right? They can get the prediction like this. And how we have done? We have the way we save the model in PMML. Some of our colleagues, they were very good in .NET. So they saved this model in C# and they created this interface, right? This interface percentage of poverty predicting using multiple regression equation, right? And I can deploy this, the C# code in any of the machine in absence of Statistica also, but still I can achieve my objective of predicting the percentage of people living below the poverty line. Does it answer your queries, ma'am? Hello?
Yes, ma'am. Yes, sir.
So basically, like this is what typically, like suppose even you have an expert in Visual Basic, right? That you can do in the Visual Basic also. Right? Visual Basic also, such kind of the interface you can create using Statistica, right? Now we are done with the regression. Now we will be solving a classification problem using Statistica automated neural network. As usual, I open an example data file. I open an example data file, open example, data set, iris. This is a very, very popular data set. Whoever is doing research in image classification or image analysis, this is one of the data set is very, very popular called iris data. So can you read data and you can identify your research problem? Just spend 1 minute and you can let me know what is the research problem and what typically we can achieve from this.
So which type of iris is identifying from the length, width, and sepals of the flower?
Yeah, and suppose I would like to see the full description of the data where, because this is not like the sepal and what does that mean? Suppose I wanted to view the full description of the data, where can I see that? Just now
All
we did,
specifications.
yeah, data,
All
all specification, right? The sepal length described as the length of sepals, sepal width described as the width of sepals, petal length described as length of petals, petal width described as the width of petals. Okay, so basically these are the properties of the flower, right? And this is the type of the flower. So what typically, like suppose we can build, and it will be a regression problem or it will be a classification problem.
It's a classification
Why classification problem?
because it will only identify the type of iris.
Yeah, because my target is the categorical in nature, right? My target is, yeah, my target variables, the iris type is labeled with classes, which is categorical in nature, right? So that is the reason it has become a classification problem or prediction classification problem, right? And to approach and solve these prediction classification problem, we will be using the same neural network. Under the data mining, I go to the neural network. I have a prediction classification problem in hand. I choose the classification. Okay. Okay. Iris type. Fine. Type. Okay. The same, like we have 150 observation of the data, right? And as like we have the option, I can split the data in training, testing, and validation. So this time just I am splitting the data in training and testing. 70% data I am holding for training and 30% data I am holding for my testing. And just mind it, whenever we build a model, broadly we rely on the testing accuracy of the model, right? My training may be more. If my testing is less, I will not consider that model, right? I will consider where my testing rate is providing me the higher accuracy. Fine. I want the specification.
Yes, sir.
Okay, once I put 0. Okay. I select all. I choose again the same, because by default it is coming. You just mind it. The last time when we were solving the regression problem, this error function were not activated, right? Because it was not appropriate. As we had chosen the automated neural network, the Statistica defines the optimum specification, and the best specifications will work out to build a good network. Here the same, but that like totally depends on my level of accuracy. I can interact, I can define my specification, like network to train, network to retain, but by default it comes 20 network to train and 5 network to hold out of the 5 best network to hold out of the 20 network. Let's train this. Can you make an interpretation in this number 1 model? N is equal to 1. MLP stand for? MLP stands for?
Sir, multi-layer perception.
Okay, and training, the rate, error rate is?
SOS. Sir, what is this? Yes.
Which one? SOS, right?
Yes, sir.
Okay.
Sum of squares.
Yeah, sum of squares. And what this BF? This is it's basically the BFGS, right? It's a broadened. So you can figure it out from Google. I'm just for. Okay, I choose this model. I go with the prediction. I will define here target, output, accuracy, and confidence level also. I went for the prediction. What you can make it out from here? What is MLP 453? Iris type output. What if I begin from the column 1? These are the case name. These are my target, which has been recorded in my data set, right? In my original raw data or the original data set. And these are the prediction, right? These are the prediction because it was recorded as Setosa, the type of the flower, and predicted also Setosa and the correct. But what is this? MLP 453.
Sir, input layer, hidden layer, and output layer.
Wonderful, wonderful. Yeah. So these the 4, 5, 5, 3. This 4 was our input, right? We had the 4 input variable. Hidden layer is the 5, and 3 was my output because we had the 3 type of the flowers, and that is the whole crux of the neural network, right? And what is the basic difference between your neural network and the deep learning, right? Here I have only one layer, one hidden layer, right? The 5. But in case of the deep learning, I can.
Sir, the hidden layer is taken now. Why 5?
Yeah, that basically we had chosen this automated neural network. So the Statistica automatically had identified what is the optimum hidden layer for this given data set. Suppose I would have chosen the customized neural network, I would have the flexibility to define my hidden layer. Are you getting me? One second.
Yes, sir. Yes, sir. Yes, sir.
Right. So there I can define my this hidden layer, right? That as a researcher, you should experiment more and more, right? But it is a very small data set. We are getting 100% accuracy in our testing data set. So that's not a big deal, right? So, but whenever you deal with a much larger data set, 1,000 rows or 5,000 rows, that is also very small, right? But you can play around, right? Even all this training, testing, validation, that also you can play around in best interest of the accuracy of the model. Right, so I get. Have you heard something like your one thing now the Statistica does not support, earlier we had, and which is one of the very important for the researcher. Earlier we were getting a neural network graph from till 7.1, Statistica version 7.1. So we were getting a neural network graph. So in that graph, basically, like you get all these weights and all these things had been defined there.
So in this particular graph you're saying, is it like predicted versus actual? Does it come like that?
No. The neural network graph is basically that will define your hidden layer, and sorry, that will define your input, hidden layer, and the output, and the hidden layer, how this the back propagation and how this error, this thing has been passing through in various hidden layers, and what the weights has been assigned from input to going across the hidden layers. So there is a very popular graph like you get in majority of the publication. Right. Right. See, I get the numerically, these are the weights, right? These are the weights has been defined, right? To pass on from input to your output, right? So earlier what was happening, this was represented in a graphical representation also, what we typically say the neural network graphs, right? Then in the output also, have you heard something about the confusion matrix before?
No, sir.
Okay, what we did for the evaluation in the regression, what the technique we applied? Just now we applied something, right? Then we find something 8 something in multiple regression, 25 something in the network. So what are those techniques we had applied for an evaluation of a regression model?
So correlation.
No, this mean square error, right? Mean square error, right?
MSE and ME, huh?
Yeah, so that is one of this your evaluation technique for regression analysis. Similarly, for classification, we have the popular evaluation technique like the confusion matrix is one of them, right? In addition to the confusion matrix, the Statistica also provide your ROC curve. The ROC stands for receiving operating curve. ROC curve, in addition to the ROC curve, Statistica also provides gain and lift chart. So these are the evaluation technique to evaluate a classification model. Fine. So here what we get from this confusion matrix.
So the third evaluation parameter was?
No, for the classification model evaluation, we have the technique like confusion matrix. We have a technique like ROC curve. We have technique like gain chart and lift chart. These all techniques are provided by Statistica. In addition to this,
gain chart,
gain means profit. Gain chart.
Gain chart.
Yeah, GAIN. Gain chart, lift chart. These are also the evaluation technique are used for an evaluation of classification model. So let's examine this, the confusion matrix, right? We had over 150 observation in our data set. Out of this 150 observation, we had hold 70% for training, and we had left out 30% for our testing. So because this confusion matrix has been constructed on your training data. So 36, 33, 36, right? Setosa, we had 36 number of Setosa type of flower. Versicol, we had 33 number of versicol type of flower. And Barzinic, we had 36 type Barzinic type of flower, right? So overall, we had 105 number of cases, total number of cases. In Setosa, we have performed 100% accurate, right? 100% accuracy. In Versicol, out of the 33, in the observed type of the flower, we have predicted 31. So 2 number, there is a misclassification. So we have achieved an accuracy of 93% in case of the Versicol. Sorry. Similarly, in Barzinic, we had 36. We have predicted correctly 34, and we have misclassified 2 numbers. So ideally, we have 94% accuracy. Mind it, this is what we have been examining. We are examining for our your training data set, right? Because in testing data set, we were getting 100% accurate in our prediction. Fine. So this is the confusion matrix I get. Fine. And you can investigate it more. We have got some kind of the global sensitivity analysis also. The global sensitivity analysis defines the predictor importance, right? Because out of my 4 input variables, my petal length that contributes maximum to determine the type of the flower, followed by petal width, followed by sepal length, followed by the sepal width. In general, what technique we use to identify the predictor importance in Statistica? The last day we had discussed, right? In a click of a button, like suppose here I have that only very small number of features are there, 4 features are there. Suppose I would have a situation, I would have 100 features, right? And I would have identified which of the features contributes maximum to the type of the flower. So what the technique we had applied last time, and that I can achieve in a click of a button using Statistica, which is typically known as feature engineering also.
Sir, can you please repeat that one last time? What you said?
The last time, like in what when we click the global sensitivity analysis, I got an output, and the output gives me like the petal length, petal width, sepal length, sepal width. Out of these 4 input variables, the petal length contributes maximum to the type of the flower, right? The petal length is the most important variable out of these 4, the input variable, right? Likewise, suppose I would have a situation, I would have 100 variables. I would have 100 properties for type of the flower, and I would have a task in hand. In a click of a button, I wanted to identify, or I wanted to determine out of these 100 input variables, which of the variables contributes maximum to my target variable. In this case, this is the type of the flower. So what the feature I would have applied? or what the technique I would have applied in Statistica. So in a click of a button, I can identify the variables. And this variable also will structured in a rank or in an order. Last time we discussed, right? We discussed about something called feature selection. Did we? Feature selection, predictor screening, right? Let's assume, right? Suppose for this data set, right? So suppose you would have such kind of the situation, very well, you can use feature selection in order to determine which information this is what I get the ROC curve also, right? Because we are getting, in case of the Setosa, we are getting 100% accurate. There was not a single misclassification was there. What we observed from our confusion matrix also. And this is the what a beautiful, colorful confusion matrix I get as an output from our model deployment. Overall accuracy, I have been receiving 98%, right? Because in case of Berzikol and in case of Berzinic, we have some of the misclassification, right? So this is the way you can complete and win with your predictive model management life cycle, right? And we are exceeding our time. We have already exceeded our time from 4:30 to 4:53, right? So any queries? So we can take the question and answer session for another 7 minutes. And at 5 o'clock, we will be signing up for today.
So we'll do this in the Statistica once, and if there is any question, we'll get back to you.
All right. Yeah, you do, and follow this example data set. And as like I will upload this recording in the Google, right? So that will help you while in your practice session, right? Then, and in case any queries will be emerging during our self-paced practice session, then always we stand by to support you.
Okay, sir.
Thank you. Thank you very much for your patience for hearing me.
Thank you, sir.
And signing up for now. Thank you. Thank you very much.